So in this video we're going to have to discuss about the vector resolution. And what is a vector resolution? And what is a vector if we intend to talk about that one? So now we have three types of physical quantities. We have what you call scalar physical quantities and also have what you call the vector physical quantities. So by the way, physical quantities, these are the quantities that can be measured. So if we say physical quantities, these are the quantities that can be measured. So they are classified into two classes. We have what you call a scalar physical quantity as well as the vector physical quantities. So what are the scalar physical quantities? So now scalar physical quantities, these are the quantities with only magnitude. So these are the physical quantities that are expressed in terms of their magnitude. Let's say we have the likes of, let's say, a distance. A distance is a part of the scalar physical quantity. And we have the time. This is the part of the scalar physical quantity. And we have a speed. This is also the part of the physical quantity. We have the area, and also we have, let's say, the volume and different things. These are part of the scalar physical quantities. And the units for distance is given in meters, can be in kilometers, and millimeters, and also even the centimeters as well. A time is given in seconds, can be in hours, should be that. And the speed is given in meters per second, and it can be kilometers per hour, and what have you. And I have the area being given in meter square, can be cubic centimeter square, and whatever can be. And the volume is given in actually a meter cube, and a centimeter cube, millimeter cube, so should be that. These are part of actually a scalar physical quantities. These are the quantities that can be expressed in terms of their magnitude. You can have, let's say, a 5 meters, a 60 kilometers, a 60 kilometers per hour. Those are part of the actually scalar physical quantities. So now, apart from the scalar physical quantities, we have what you call the scalar vector. Actually, should be the vector physical quantities. So what are the vectors? So these are the quantities with actually magnitude as well as the direction. So these are the vectors with magnitude as well as the direction. So the vectors specifies the magnitude as well as the direction. So for instance, we have, let's say, the displacement is the part of the vector quantity. So displacement is the part of the vector quantity. And we have the velocity is also part of the vector quantity. We have the momentum also part of the vector quantity. And even that of the force is also part of the vector quantity. And we have what you call impulse. This one is also part of the vector quantity. So we have a lot of examples to do with the vector quantities. Even the torque as well. This is also part of the vector quantities. So what happens? You can have, let's say, 6 kilometers to the light. So which means you can have 6 kilometers to the light. So which means a kilometer is actually magnitude. To the light means the direction. That's the displacement. Let's say we can also have, let's say, a 60 kilometers and 90 degrees. It means a 60 kilometers. It means the distance. And 90 degrees, it means the direction. So take note of that. And the direction can be given using, let's say, the cardinal points, that is east, west, north, south, whatever. And that can also be given in terms of the positive or minus. So let's say 6 meters should be, let's say, negative 6 meters per second, means this is the speed and this is the direction. Hence, the whole of that one is the velocity. So which means the object is, let's say, it is going towards the left or towards the down. So that's the essence behind the negative. It is showing the direction there, so it is part of the velocity. So the direction can also be given in terms of, and that should be angles. So that's what you call the bearing. we can have, let's say, the object moving 20 kilometers per hour about 60 degrees. So this is the magnitude and this is the direction. So take note of that. And we can have the object moving about, let's say, the force acting at an angle of, let's say, 60 degrees. And that should be the force of, let's say, magnitude, let's say, 5 newtons at an angle of, let's say, a theta given at 60 degrees. So which means this is the magnitude and this is the direction. So that's the part of the actually a vector physical quantities. So now, let's say we have a vector. That should be this case. Let's say we have a vector. Let's say it is a force. A vector, let's say a force, given as F. And it is acting towards this direction. And let's say it is acting towards this direction. And mind you, have to understand this case. A vector is presented by the straight line with an arrowhead. So let's say for this case, let's say it means this is a vector because it is having the arrowhead in that case. Let's say we have 5 newtons, it means this is the 5 newtons as the magnitude towards this direction. So the vector is presented by the straight line with an arrowhead. Arrowhead shows the direction. So take note of that. So now, for instance, let's say we have a vector going off like that. Let's say it is given as a vector F. And let's say this is the direction. Now, assuming that the direction has been presented, let's say, with an angle with respect to the horizon, let's say this is the angle in which the vector is being pointing to. Let's say that's the case, and the angle has been measured from, let's say this is the Cartesian plane. You should have to understand as well properly what is all about behind everything. In this case, what it means is this one. Now have this as the Cartesian plane presenting in that case. Now, which means the angle has been measured against from should be x-axis. And this is the direction in which the force is being pointing to. So now, you should have to understand about one thing. Let's say this is a point A. That should be this. Let's say this should be a point O. And this is, let's say, a point B where the force is pointing to. So now, this is the actual direction, and this is the magnitude which is given as the force. So, assuming that there is no a direct path, and from O to P, in which the force can be exerted, or in which the vector can be go up to, what can be the another alternative in which can have to go for to have from O and to P? So what is that one? Well, we have another alternative, and that we can go like this. So it should be this. We have an alternative. We can go like this. Should be that, and I also go like this. So now, which means we'll have it this way, and also this way as well. So now, let's say this is a point A. So what does it mean here? It means instead of having a direct path from O to P, we can have some other actually alternatives. We can move from O to N and having N to P. So what is those actual alternatives? So ON as well as NP, that's said to be the components of the vector F. So those are said to be the components of the vector F. And mind you, what we have here is 90 degrees, hence we have the ladder in the triangle. So much as we have the magnitude and the direction which is the angle here, then the components can be expressed using the trigonometric ratios, that is over rho. So now which means here we'll have it as this is x component and this is the y component. So these are said to be the components of the vector. And in the process of splitting the magnitude of the vector into the components is what we call the vector resolution. So now the process of having these components from the magnitude, that's said to be the vector, it is said to be the vector resolution. So take note of that, which means as it stands here, if this is the Lagrange triangle, it means this is the hypotenuse, like that. So if this is the hypotenuse, what is the value of the component x? So now this is adjacent, this is hypotenuse. So which means we'll have it as a cos. So which means we'll have cos a theta is equal, now we'll have adjacent x divided by hypotenuse, which is given as f. So which means x component of the force is given as f cos theta. And how about the y component? So y component will be given as a y is equal to f sin theta using the same trigonometric ratios. And of which, to be more realistic, we can have it in this case. In that case, we'll have it as f of x, that is f subscript x, and I'll have it as, now should be f subscript y. So that shows that these are the components of the force given as f. So now, take note of that. And you should have to know that the direction in which the components has to be, it obeys what you call the triangle law of Avogadro vectors. What it means is that if the vector is pointing this way, it means the components also has to follow the same path, in the sense that will go like this and also go like that. So it should be actually given that way. And for instance, let's say if the magnitude is in this way, let's say that is the case, it means the components, I should have to be in this way. Let's say this was the case, you should have to understand it properly. Let's say this was the case, you should have to know in this way. Let's say we have a vector which is going over like this, and say this is a vector f. Now assuming that it is now acting against the horizontal at an angle, let's say given as theta. So how will we be able to resolve this one into components? So now the best way is to come up with a Cartesian plane. In that case, so have it in this case. So should be this. Now let's say it is in this case. Let's say actually the vector is acting, the force which is the vector, it is acting at an angle, let's say a theta, with respect to the horizontal. Now how should we be able to resolve that into components? So first thing, try to have the Cartesian plane, and from that one, so you have it in this case. Now you can see it properly. So which means upon resolving, you may think of having this case. Let's say now you have it in this case. So it should be, you have this case. That should be that. And you also have this case. So now it should be that. So now since the direction is in this way, it means the components also has to follow the same way. So now we have in this case, also in this case. So please take note of that. So now since the x component is pointing towards the negative, it means the x components will be given as the negative. as we'll be resolving. And the y component will also be given as negative because it is pointing towards the negative direction. So take note of that. And you should also have to understand this thing as well. You should have to understand that what if a vector is acting at an angle with respect to the vertical, which is the y-axis. Let's see now this is the case. We have this, should be now this case. We have this as the vector. Let's say it is going off like that. A vector given as f. And say it is acting at an angle. Let's say it is acting at an angle. Let's say that's the case. At an angle theta with respect to the vertical, which is the y-axis. So how should we be able to resolve that into components? So now principle means the same. Try to have the Cartesian plane, that is, I don't know what is happening with my drawings. Anyways, no one is perfect, so bear with me. So now in this case, we'll have this and this. Let's say that's the case. So now which means you have that thing being given in this way. So now you can see that you can be able to resolve that into components, and of which you will have this is being given as this. And you have it in this case like that. Of course, you have to complete that one to be in this case. Now what we have is the right angle triangle, where I will have it being given as that. Let me have it in this way, not like that. Otherwise, I may end up confusing you. Should be in this nature. Now, since the angle is against y-axis, now the resolution has to be in this way. So we'll have this case. Now this is the 90 degrees like that. So which means even the components has to fall the same way. We'll have that and also have that. So since the components are pointing towards the positive directions, all of them will be positives. So take note of that. So now this is a y component, which is fy, and this is fx, which is the x component of the force, or the vector rather. You understand that fx now will be given as f for sin theta, since the angle is against y-axis, and fy will be that of f cos theta, like that. So don't memorize. If the angle is against y-axis, it means along x-axis we'll have sin theta, and along y-axis we'll have it as along x-axis we'll have it as a sin theta, and along y we'll have it as a cos theta. So what is happening, because this is the opposite, and this is the actual hypotenuse, that is on the trigonometric ratios we'll have it as a saw. Now this is the opposite, this is the hypotenuse. So this will be the actual x component that will be symbolized, that will be given, that will be expressed in terms of sine. So let's try to go over these actual problems and see how should be able to resolve the vectors into components. Let's say we have the force given as 20 newtons. Let's say at an angle, let's say theta, with respect to, let's say at an angle theta of, let's say, f49, with respect to the x-axis, that is the horizontal. So what is that one? So now first thing, I have to come up with a sketch. How is that force acting up to? So I'll have my horizontal line and having it in that way. Since I'm told that the vector is acting against the x-axis, which is the horizontal. So in this case, I'll have this as my vector, which is given as f is equal to 20 newtons. Then this is my angle, which is given as 49 degrees, like that. So how should you be able to resolve that into components? So now, which means I'll have it in this way. So I have to complete that one in this way. So I'll have to do this. And this one provides actually a track to see what is the nature of your system of the vector. So now this is my right angle triangle, where this is 90 degrees. Now I'll have the actually like that and also like that, according to the triangle of radical vectors. So this is my fx and this is my fy. So now since the angle is against x-axis, it is fine. Now I'll have fx being given as f sin theta. So it should be that. And I'll have fy being given as f, now should be f cos theta, no sin theta. So now I'll have it as f cos theta. And all components will be positives because they are pointing towards the positive directions. And I'll have f sin theta. So what is fx? I'll have it as 20 newtons and the times cos of 49 degrees. So what's that? So now which means we'll have it as 20 times cos of, that should be 49 degrees. That will be given as 13 point, let's say 12 newtons. How about fy? We'll have it as 20 newtons times the sine of, let's say 49 degrees. That will be given as, so what is that one? So have 20 times should be sine of 49. That is given as a 15.09 newtons. So these are the components of the vector in that way. So this way it means we have resolved the vector into components. And what if we have this case? Let's say we have it in this way. And say we have a vector that is going off like that. Now it is in this way, and it is acting, let's say, at an angle. Let's say at an angle of, let's say, given as 25 degrees. Let's say the vector is given as the velocity, which is given as, let's say, 2 meters per second. So what are the components of this vector? So now principle remains the same. I may suggest of having this way, it is fine as well. So I may have to present the Cartesian plane and where the vector is acting onto. I may have that. And predefine this knowledge will be very important because we also have another method in which we can be able to resolve the vector into components. So this knowledge will also be very important as well, as you may think about it. So I'll have that. So which means as I'll be resolving the vector into components, I'll do this. So which means I should have to think about this. Then I'll have to proceed that one up to that one, and also this one up to this point. So now which means this is a 90-degree angle, and this is my velocity, which is given as 2 meters per second. So what would be the directions? We can have it as in this case. We'll have it in this way and also in that way. So now as you can see, x component and y components both will be negatives because they're pointing towards the negative direction. So that's the goodness with knowing the direction of the components based on the direction of the magnitude. So take note of that. Rather, based on the direction of the actually a vector you are dealing with. So in this case, we'll have it in this case. We'll have a Vx being given as negative V cos theta, since the angle is acting against the x-axis. And we'll have Vy, that will be given as negative V cos theta. Should be sin theta, rather, should be sin theta. So we'll have it as, in that case, a sin theta. So try to have your solutions there. Now what if we have this case where now the vector is acting against the vertical axis, that is x-axis, that is y-axis? How should we be able to resolve that into components? Let's say if this is the case, we have this as the vector going over as that. Let's say it is given as, it should be a momentum. It is given as 2, should be now 2 kg meter per second. That's the momentum. And let's say it is acting at an angle with respect to the vertical axis. That is given as that. Let's say this is the angle theta. Now how should we be able to resolve this onto components? So now principle remains the same. We'll have to come up with a Cartesian plane that way. That will give you a way to go. Of course, I may think of having that or not first. So I'll have that as that. Let's say in this case, I'll have this. Should be now. I'll have this. So in that case, this is my vector, which is a momentum symbolized as a lowercase b. So which means since the angle is against the x-axis, actually y-axis, then this is how I can do. So I'll have that. So in that way, I'll have to proceed this one this way. So this is my 90-degree angle like that. So this is my bx, should be by, and this is my bx. So since the angle is against the y-axis, it means I'll have bx being given as a b sin theta. And I'll have b, now should be directions now, I should be very careful with that one. So I have by is equal to b cos theta. So all components should be negatives because the angles against, because the directions are instead of towards the positive directions. So bear that in mind. As now, sometimes you may just have to say, much as the angle is against the, let's say, x-axis, I'm no need to have the sketch or whatever, but it is very important to have the sketch because it gives you a guide to how will you be able to have your resolution concept in that case. Now let's say we have the system of the forces, should be the system of the vectors. Let's say we have and say we have this vector which is given as, let's say, f1 is equal to, let's say, 2 newtons, and we also have this vector and say it is given as, let's say, f2 being given as 10 newtons. Let's say that's the case, and it is acting against, should be horizontal at 10 degrees. And then now we have another vector which is going over like this, and it is in that nature, and let's say this is given as f3. is given as the 5 neurons, and it is in this case. Now let's say that's the case. The angle is given as 30 degrees, and say we have, in this case, we have another vector which is going over like that, and say it is let's say that's the case, and it is going over in this way, and it is at an angle. Let's say this is f4, which is given as, let's say, 20 neurons. The angle is given, let's say, 15 degrees, so it should be that. And let's say we have another vector, and which is going like that, that way, vertically upward. Let's say f5, which is given as 5 neurons. Let's say like that. And we have another vector which is pointing downwards, and that should be that. Let's say f6, given as 1 neurons. And now we have another vector in this way, now going over in this way. The vector is going that direction. Let's say f7, which is given as 8 neurons. So now resolve these vectors into components. So let's start with f1. So now, as you can see, f1, it is acting along x-axis, or said to be, it is acting in the horizontal axis, and that was the positive direction. So what is the angle between? So the angle with respect to the x-axis, it is given as 0 degrees or 360 degrees. So hence we'll have f1x, that will be given as 2 cos 0 degrees. So it should be cos 0 degree. That will be given as the same 2 neurons. How about fy? f1y, we'll have it as 2 sin 0. That will be given as 0. So which means whenever the vector is acting along the x-axis, in that case the y component of that vector is given as 0. So which means in this case we'll have it as that. Or even if you may think of having the angle being given as 360 degrees, also be the same way. So in other words, whenever the vector is acting along the x-axis, the y component in that way it is given as 0, and the x component is the same vector. So that is, so which means for the vector f1, these are the components. So now since it is going towards the positive, it means we'll have the positive in that way. So take note of that. Now what if we have this case? Now what if we have, let's go for f7. So f7 as well, it is acting along x-axis but towards the negative actually a direction. So now which means we'll have f7x being given as negative 8 neurons, and f7y will have it as well because actually the vector is acting only along x-axis, hence cannot be so resolved into y component. So take note of that. And the negative shows that the vector is pointing towards the negative direction. And let's go for f6. It should be f5 first. f5 is acting along the vertical axis, which is along x-axis, and that is which is along y-axis, and that is pointing towards, and that is it is pointing towards the positive actually a direction. So if that's the case, then f5x will be 0 because the vector cannot be resolved into x. Rather, I'll have f5y being given as the same vector, which is 5 neurons. since it is moving towards, it is pointing towards the positive direction. So have that understand. The rest call for should be f6. Now f6, it is also acting along exactly the y-axis, but now towards the negative direction. So which means we'll have f6x, we'll have it as L, and f6y, we'll have it as negative 1 newtons because it is pointing downwards. So take note of that. In the direction of the directions of the components should be very careful with. Now let's go for. Now let me just have to eliminate this, the ones I've already dealt with. So we can have this out. So that is. So let's go for actually f2. So you have to resolve that into components. So you have to do this in this way. We can have this. So which means we'll go like this and go like this. And the process of coming up with the sketch tools actually helps you to have to know what will be the nature of your components. Will they be either positive or negatives? So in this case, it means that our components will be positives because they are pointing towards the positive directions. And on the same note, the angle is against x-axis, which is fine. So have f2x, or have it as f2, and that should be cos actually 10 degrees, of which f2 is given as a 10 newtons cos of 10 degrees. So you have that out. And f2y, you have it as a 10 newtons a sine of angle 10 degrees. So try to have that out at your own time. Mind you, care has to be considered whenever we are dealing with the components based on the directions. Now how about this one? Now you also have to do the same way. Of course, that's the same way to go. We'll have that where this one will be given as f3x and this is f3y. So since the angles are against x-axis, which is fine, but the components will be all positive, will be all negatives because they follow the same path towards this one. So in that case, we'll have f3x being given as negative f3 cos of 30 degrees, of course. And our f3y, you also have it as negative f3y and our sine 30 degrees. So you should have to know that. So in case you are being asked during the exams, you should be very clever on these things. And the rest go for f4. What will happen? You also have the same principle as well. So now, which means you may think of having this case. So we can go over like that. And I should have it in this case. So like that. So which means the components also have to follow the same path and for the actual magnitude. So which means in this case, both will be positives because they are pointing towards the positive directions. So now we'll have it as, since the angle is against x-axis, which is fine. So it is okay with that one. So try to have that one out on your own. And what if we have this case as well? We should have to see much about. Let's say we have it in this case. We have a vector which is acting against the horizontal. Let's say this is an angle. Let's say it is given as 20 degrees. And the vector is given as, let's say, f. It should be given as 5 newtons. So now how should we be able to resolve that into components? So now principle remains the same. So which means since the angle is against actually y-axis, it means along x-axis. So let me just have to So which means I'll have it in this way. So this is fy, this is fx, where I'll have it as, now the directions will be in this way. So since all components are going towards the negative, it means the components will be negatives. So I'll have negative f s and theta, because the angles against the x-axis should be y-axis. And I'll have fy being given as negative f cos theta in that way. So take note of that. So there is another alternative, and which I prefer, which I recommend as well, that it is the best one. So this actually method does not really need you to think about, well, I have the negative or positive in my components. It just tells itself how it have to be. So what is that actually alternative? So for instance, let's say we have a vector going over as that, and let's say we have it in this case, and it is acting against the horizontal, let's say at an angle of, let's say, 30 degrees. Let's say that's the case. Of course, we know that we should have to resolve the force, let's say the vector, into components. Let's say the vector is given as F is equal to, let's say, 30 newtons. So we should have to do it in this way, and of which you need to be very careful with the directions, or have in this way, also in this way, of which, by as far as the vector resolution is concerned, we'll have fx being given as the negative. We'll have this as y, fy, that will be given as the positive, because the x is pointing towards the negative direction, and this one is pointing up, which is actually a positive direction. And the rest you should have to resolve that one. So now, since the angle is against x-axis, it is okay. The which is that of now being given as, we should have it as 30 times cos of 30 degrees. So have that on. So which means we'll have it as a 26, will be negative 26 newtons. We are pressing 26 because we are having 26 actually a negative, because the component, because the vector or the component is towards the negative direction. So that is, and I'll have fy, which is pointing towards the positive. So now I'll have it as a 30 newtons and the times the sine of angle 30 degrees. So now what would be that one? Let's say we should have it as 30 in times sine of 30 degrees. That would be given as, now should be 15 newtons. Since it is pointing towards the positive, we'll have it as a positive. So what is this best technique I'm going to tell you here? So this technique, I said, does not require you to think about whether the vector will have the components that are going towards the negative or positive. It tells itself. And no matter whether the vector is against the horizontal or the vertical axis, no, it tells itself. How would you do that? Now we have this case, which is the vector given as f is equal to 30 degrees, as should be 30 newtons. Let's say that's the case. Let's say that's the case, given as 30 newtons. Let me probably have to, because I may need some space here. Let's say we are having that vector going over as that, and this is f is equal 30 newtons. Let's say the vector has to go as far as this, and say the vector is acting against the horizontal. let's say at an angle given as, let's say, a 30 degrees. So what is that technique? So now first thing, you have to have the Cartesian plane, 2-dimension Cartesian is actually plane that way. So you have this. The next, you should have to calculate the angle from the positive x-axis until where the vector is. So we need this angle, which is this. We need this angle. What is that angle? So if this is 30, it means this angle is given as 150 degrees. So now according to this technique, always along x will have cos, along y will have sine. So which means we'll have fx will be given as, now instead of 30 we'll have 150. So have it as f cos 150. And basically it would be a negative upon actually punching that on the calculator. So have it as 30 in the times cos of 150 degrees. So what would be that? It is given as the negative should be a 26 as it was before. So negative 26 neurons. So that's the beauty of this method. Despite whether the vector is against x or y, but that's the principle behind. And how about fy? Now have fy being given as, or have f a sine of 150 degrees. So what is that one? So have a 30 times sine of 150 degrees. That will be given as a 15 neurons is the positive one. So have it as a 15 neurons. So that's the beauty of that method. Let's say we have this case. Mind you, we are not much caring about whether the vector is against x or y, but what we care about is that we should have to measure the angle from the positive x-axis until where the vector is. That's the essence behind. Let's say we have this vector, which is, let's say f is equal to 10 neurons, and say it is acting in this nature. Let's say at an angle should be a 47 degrees. So what are the components of this vector? Of course, using the method we discussed before, we'll have to resolve that into components, and that will be governed this way. Of course, you think of having, no, should be this, of course. Of course, you should have to think about this. Of which should be this is f is equal, what was it? Let me just have to give it 10 neurons. I forgot what I had there, but anyway, that is, so which means I'll have it in this way. That is if I'm to be much realistic with the method that we discussed before. So have that and as that, and of which this is 90-degree angle, and the components has to be equal like this. So since the angle is against the x-axis, it means we'll have fx being given as, and since x is pointing towards the negative, it means we'll have negative should be 10 neurons. Now cos theta should be cos 10, should be cos 47 degrees. So what is the answer there? So now which means we'll have it as a 10 times cos 47. That will be given as 7 neurons. So have it as negative 7 neurons. And how about fy? Now since it is pointing towards the negative, it means we also have the negative 10, and that should be a sine 47 degrees. And that will have it as now negative 10 and the sine 47 degrees. Now also have it as, so what's that? And that should be this. Let me have it properly. We have a 10 and the sine of 47 degrees. We have it as a 7.3. So negative 7.3. So these are the components. Let me come back about that one. I should have to confirm. Which is 10 cos of 47. So we have it as about 6.8. Should be 6.8. So which means I'll have it as a 6.8 newtons. So take note of these components. Now let's use the method that we discussed recently. This is the very beautiful method that not require you to go over and think about I should have my actually components this x, this y. No. This method requires you to know about the to know about the geometry, because it uses the same concept of the geometry. That is the angle property actually. That is about the angle properties and some stuffs. Let's go for this case. Let me just have to take it out here. Should be the whole of that one. So I'm having this. And I'm having this vector. And we say it is given as f is equal to 10. And the angle is given as 47 degrees, of course. So you should have to develop the two-dimensional coordinate system we have been talking about. Should be this case. Of course, this is like that. So what is the angle measured from the positive x-axis anti-clockwise until where the vector is? So this is the angle of interest. So what is that angle? It means this is 180 plus 47. So what's that? So 180 plus 47, so should be 180 plus 47. We'll have it as 227. So the whole of that angle is given as, no, it should be this. The whole of this angle is given as 227. So which means this is the angle that we had to use in the resolution case. So now have it as fx being given as, now without thinking about what would be positive or negative, but we just have to punch with the calculator. The answer will be a right on its own from the calculator. So have fx being given as a 10 should be a cos 227. This one, no matter whether the angle is against x-axis or y-axis, but the principle has to be in that way. We can have it as 227 degrees. That will be given as, now have 10 times cos of 227. That is now negative 6.8. As we had it before, negative 6.8 newtons. So also try that on another method. Actually, also try to have that of fy. Actually, fy also be the same way. So that's the beauty of this method. And what if you have this case? This one much actually does not consume much time. You know, just have to quite basic stuffs, then you're done. 47 degrees we had it here. So I mean, what if we have this case now? Let me just erase it all. So in this case, what if we have a vector and that is going like this? Let's say this is 30 degrees and this is the vector, let's say a 4 newtons. Of course, since the angle is already against x-axis, a positive x-axis, like this, it is okay. No problem. So we just have to make use of it the way it is, because the angle has been measured from the positive x-axis and are actually anti-clockwise, which is fine. But what if we have this case, and basically for the method I'm talking about here, that's when you should think about that. And let's say we have this case. We have, let's say, a vector f given as, let's say, 20 newtons. And it is in this way. Let's say it is acting in that case. That this is, let's say, 20 degrees. How should you be able to resolve that one in that way? So from this method, you have to go like this. So you should have to think about this one as well. And for the blower track, so what is the angle measured from the positive x-axis and clockwise until where the vector is? This is the angle. So you have the whole of this one. So what is this angle? 360 minus 20 degrees. We'll have it as 340 degrees. So this is the angle you have to use, and it really tells you that we'll have whether it really tells you that along x-axis we'll have the positive, and along y we'll have it as a negative. It really tells you that. So that's the beauty of that method. What if the angle is against in this case? Let's say a vector is in this nature. Let's say the vector is in this nature. Let's say this is the case, 20 newtons. So what would be that one? So now principle remains the same. No matter whether the angle is against y-axis or what, but this method works best. So you have to go like this. And this is the angle of interest, the whole of this angle until where the vector is. What is the whole of that angle? You get it right. So now at your own time, try to have the following. Try to resolve the following vectors into components. Let's say we have the system of the vectors. And that should be this. You should have to try all the methods, 2 methods I've taught you here in this video. You appreciate. Let's say we have this vector, let's say at an angle of, let's say this is f1 given as 60 newtons. The angle is given as 20 degrees. Mind you, as it stands here, principle remains the same. We'll have to measure the angle from the positive x-axis and clockwise until where the vector is. So this is the angle. We'll have to use this angle. And you should also have to try if we are to use this angle based on the first formula. Actually, it should be the first method. You also get it in the same way. And what if we have this case now? Also, we have this. Let's say this is the angle given as 65. And it should be given as, this is f2, 80 newtons. Let's say that's the case. Try to resolve that into components. And let's say this is a vector as well. And it is in this way, given as f3, given as 100 newtons. Try that one as well. Of course, it is already in y-axis. It will be just that. Let's say we have this case. Let's say this is the case. And there should be f4 at an angle of, let's say, 35 degrees. The f4 is given as, let's say, 50 newtons. How should we have that one? And say we have another force, or the vector, which is in this way, which is given as f5. Should be given as the 10 newtons. Let's say this is the angle given as 47 degrees. So what is that one? Try to resolve those vectors into components in that way. So please take note of that. So next we're going to look at some of the cases to do with a vector actually result of the vector. That is, how should we be able to have the actually resultant as well as the direction. It should be magnitude as well as the direction if we have been given the actual components.